All right, so the most recent version of Sodium introduces 5 new settings under Advanced, these 5 settings here. And these settings all control the chunk builder thread creation. In this video, I'm going to quickly explain what these settings do, how they fix F3F lag, and how you might want to change them yourself in order to tweak your own performance or test out different configurations. That being said, before we get started, I should mention that the default values for this are probably all fine for most people, unless you really want to eke out some slightly better chunk rendering performance. And you probably don't need to change them, but you can probably get some improvement depending on what you're playing, what category you're doing, that sort of thing, if you tweak them a little bit. All right, with that out of the way, this video is going to be divided into 3 parts. In the first part, we're going to go over what F3F lag is caused by specifically and how it's caused by Sodium chunk builder thread creation. In the second part, we'll talk about what each of these settings do individually and what their auto values are. And in the third part, we'll talk about a couple different potential ways that you might want to tweak the values and what the outcomes of that would look like based on our understanding of the performance implications of these settings. All right, so firstly, let's talk about F3F lag. So if you've been doing Minecraft speedruns recently, you've probably noticed that there's been a lot of issues with F3F causing massive lag spikes. So if you spam your render down, and then you spam it up, and then you spam it down again, this usually leads to massive lag spikes for a lot of people. The reason why this is, a lot of people theorized it was caused by CQ, but that's not the case. This is actually caused by Sodium. So we're going to go over this really simply, what this does. We're at a super high level. Basically, the reason for this is that every time you press F3F, or really anytime you change your render distance at all, Sodium will look at the number of threads that you have available. So for example, I'm on a 5900X, so you can see it's 12 cores, it's 24 threads. So Sodium knows that I'm on a 24 thread CPU, and every single time I press F3F, it will create 24 threads for chunk building. What chunk building is, it's different than chunk generation, but that's probably all you need to know. Basically, having more threads makes it so that chunks appear on your screen faster. We don't really need to go into the details of that. So when we spam F3F, it's going to keep on making 24 threads every single time, 24 chunk builder threads. And the reason all these chunks appear so quickly, I mean, they're already generated, but they appear really quickly because we have a lot of threads all working simultaneously to build the chunks for the client rendering. The issue is that unfortunately, the way that Sodium does this, well, first of all, doing a bunch of stuff every time you press F3F is not stellar, especially if people are spamming it up and down. But secondly, the way that this is done really just isn't super efficient, and this causes a lot of issues, especially on Windows, when these threads are all cleaned up. The reason why this issue is mostly experienced after CQ is introduced is because this issue is only really visible or present when you have a large amount of memory allocated to Minecraft. In other words, allocated to Java. When the memory allocation is lower, like most people were doing with Wall, but prior to seedq, like 2 gigabytes maximum, this issue isn't really present. You can't really experience it quite as much, even though the same performance issues are still technically there. All right, so to summarize, basically every time you press F3F, it creates a bunch of chunk builder threads based on the number of logical threads you have with your CPU. This is really laggy, and that's not great because it leads to extreme lag spikes when you're spamming F3F to change your render distance, say between 32 and 2 or vice versa. That being said, the number of chunk builder threads you have does directly impact the speed that chunks are visible on your client. So with fewer threads, the chunks would not render quite as quickly as they do here. If we were on, say, like 2 chunk builder threads, we wouldn't be able to see the chunks quite as quickly. All right, so now that we have context for this, we can talk about what these settings actually do at their default values and what the different values do. So essentially, the way that we fixed the problem is that we gave users control and changed the defaults as well over how the threads are created. So originally, Sodium would create just a flat number of threads every single time you press F3F. But with this, you're able to configure the number of threads you create at every stage of the process. So we've split it out into a 3-stage process instead of what it was before, which is just, it would just directly create a bunch of threads. Now we have our initial chunk threads, our target chunk threads, and our maximum chunk threads. And between each of these stages, the new Sodium will progressively create threads in order to make it to the next cap. So every single time you press F3F now, or every single time you change your render distance, we will immediately create the number of initial chunk threads that you have set by this setting here. So right now it's set at auto. Now for the initial chunk threads, and only for the initial chunk threads, this isn't just a flat value. This will actually scale and change depending on your render distance. So as you're modifying your render distance, you'll get slightly more initial chunk threads if you have a higher render distance. But it's not a high enough number, even at the maximum, to cause F3F lag in any cases that we've observed. Then we have to get from the initial chunk threads to the target chunk threads. By default, this is a larger number, but you can set all of these to the same number, and then you just will have the same behavior that the game had before. But by default, this is going to be some percentage of the number of logical cores your CPU has. So for example, say before you had a Ryzen 5900X, every time you press F3F, Sodium is creating 24 chunk builder threads. Now this is going to be something like, I don't know, 10 or 12 or something along those lines. You can check the algorithm if you want, but whatever, this is just an auto setting. It's a decent value, it's not a big issue. In order to get from the initial chunk builder threads to the target chunk builder threads, we have to create some. And we don't want to create them all immediately, because if you're spamming F3F, that means that you might have threads created that didn't need to be created in between that like time span. Instead, we chose 100 milliseconds as a default interval between each thread creation. So this means that, say there's a difference of 10 threads between these two values. So you have, say, this set to 2 and this set to 10 or something like that. That's not a difference of 10, but you get what I mean. Within 1 second, you will still have the same number of threads that you would have had before if you had just only had this value. So you'd be loading chunks pretty quickly, very quickly, within 1 second. But because these are created on a delay, if you're spamming F3F, that actually just never happens until you stop spamming F3F. So basically, that's what this is for. This allows you to set the number of threads you want to have as soon as possible, but generally after you finish spamming F3F. Finally, we have the maximum chunk threads. So I split this out into 3 different settings because I thought that it might be useful for long-term performance benefits, depending on your specific use case, to be able to configure an even higher number of chunk threads if you don't change your render distance for a longer period of time. So in this case, the value for maximum chunk threads, say this is something like twice as many as your target chunk threads, every 1 second, so this is also in milliseconds, so this is a different interval, this is the interval for these two, this is the interval for these two. I don't know, maybe that's overcomplicated, but whatever. Every slow thread creation interval, milliseconds, so this is 1000, so it's 1 second, we'll create another thread until we hit your maximum chunk threads. So say you set this maxed out at 64, over like, say, 30 seconds, you're going to create all of these additional threads. And then as long as you don't keep on changing your render distance at that point, you're just going to have, generally speaking, faster chunk building times. The impact on actual time to load 32 chunks is noticeable, but it's not gigantic. So if you find that this ends up slowing you down in other ways, you can probably set this to a much lower, more sane value. By default, this will be set to what Sodium had before. So the main goal of splitting things out like this and then also having auto settings was that after approximately like 2 or 3 seconds, you're going to have the same number of chunk builder threads running that you did before any changes were made to Sodium. And of course, the reason for that is that we don't want to see any performance regression in chunk building. We want to get the exact same amount of chunk building speed that we had before the change, while also fixing F3F lag with this delayed thread creation that technically slows down chunk building at the very start when you're spamming F3F, but then quickly ramps up so that you still end up having the same speed. So just to reiterate what we were talking about earlier, before you would have the number of logical cores set as your maximum chunk threads. So I have a Ryzen 5900X, it's a 12-core, 24-thread CPU, which means that this value on auto is the same as this value on 24. It's just hard-coded to that. This value is approximately 9 or 10, something around there. And this value, if it's set to auto, is going to change based on our render distance. So say we're at 2 RD, it's going to be at 2. And also, even if we're at 3 or 4 RD, it's not the same value, but you get what I mean. All right, so I think we've covered everything we need to cover about what these values do. Now let's talk quickly about a couple of different examples of where you might want to configure them depending on your use case. So for me, I play a lot of AA and I care about long-term chunk building performance because a lot of the time I'm loading and looking at 32 chunks while flying. That means that I probably want to set a higher maximum chunk threads. Now this is something you can play around with because I only have so much ability to profile this. But I found that a value in the 30s for my CPU, which is approximately like a plus 30% over my logical cores, does seem to get me like a noticeable increase in speed of chunk building times. The other two values, quite frankly, I would leave at auto. I don't think there's really any reason to change these. They're just there in case you want to hard code a lower initial chunk threads. For example, say you're frequently spamming F3F, but you really don't need that initial chunk building time. You can just hard code this to 2, and that's the minimum value. So that might help a little bit with F3F lag if you still experience it after this change in like even a small way. The target chunk threads, there is a different configuration that was suggested to me by, I think, Tilda Justin, which is that you could do something like this, where your initial chunk threads and your target chunk threads are only 1 apart. And then based on your key repeat intervals, so say your key repeat is like, 200 milliseconds, you could set this to like roughly 205 or something like that. It's not going to make a huge difference. It's a very short period of time anyways. And this would make it so that whatever your initial chunk threads are, if you're spamming F3F, you would just get this for every F3F. And I forgot one other thing. You would have to set the slow thread creation to be really low for this to work properly. But effectively what would happen is that you would spam F3F, you would only make 2 threads every single time. But then as soon as you've stopped spamming F3F, you would immediately get your maximum chunk threads because this is only 1 millisecond. So it would be basically instantaneous. And this would mean that you almost always have this number of threads active, except for specifically when you're going up and down between render distances. I personally wouldn't suggest this because I think that if you did F3F a bit slower, say you were like pyraying or something and frequently crossing chunk borders and changing your render distance, you might notice that you would still get F3F lag with a configuration like this. But it's possible you wouldn't. You're free to play around and try that sort of thing out. Finally, if you're on Linux and you just don't want any of these changes, you can set your initial chunk threads and all your other configurations as well to whatever value you want. So again, if you want to get the exact same performance you had before and just not think about this whatsoever, you would just set all 3 of these to whatever your logical core count is. So for me, it would be 24 on all 3. But if you wanted to get slightly better chunk builder performance, you could like raise even just the maximum chunk threads and slowly get better chunk builder performance. All right, so that's about it. Hopefully this is helpful. Just quickly, I'm going to shout out a couple people because this was a crazy issue to look into and debug and bug fix. Dougal actually figured out the initial fix for this by pinpointing that it was related to the number of threads that JVM had access to. Jojo essentially fixed the problem. Jojo's a goat, and I kind of griefed him a little bit. So my apologies, Jojo. But Jojo basically fixed this issue like 2 months ago, so also a legend. And thank you, Contaria and Tilda Justin, who are also very, very, very cool people who do a lot of work behind the scenes, making sure that all of your mods get updated and are bug fixed and properly performance tested and that sort of thing. And that's it. So hopefully this is helpful, and enjoy not having F3F lag.